Good morning. Today we are correcting CO58, determining whether polygons are congruent, similar, or neither. It's important that we really understand this because we're going to build on it with today's objective. So we really have to know what it means to be congruent, where they are identical measurements, to be similar, where they are proportionate. They're getting bigger or smaller at the same rate. All the sides are proportionate, or neither. They're different size shapes, different shapes, different everything. So let's look at our second page. If you are drawing something congruent, you are drawing them to look identical. So every side should match up. All the angles, you should be showing that they are identical. Do we have to put in angle measurements? No, we don't have to put the actual measurements in, but we do have to put in those arcs to show that they are congruent. For the similar, I'm not sure why people are feeling the need to talk and be silly. Let's be quiet, please. For the similar, the shapes should be similar shape, but one big and one small. You could put in measurements on the sides to show that they are proportionate. So if I put 10, 8, and 6, and then this is 5, 4, and 3, I know they're proportionate because I'm dividing by 2 from each side. So I divided by the same number on each side. And then for the neither, you're going to make your shapes look very different. So it is obvious to be similar, they have to be the same shape, just a different size. So if my triangles are two different shaped triangles, it's obvious that they are not similar and they're not congruent. Okay, does that make sense? So in the middle, determine whether the polygons are congruent, similar, or neither. Explain how you know. You can't just look at it and say, well, it looks like they're proportionate. We actually have to show that they are proportionate. So the first one, we had 12 over 19, and we have 11 over 16, and 9 over 14. When I divide them, they do not get the same decimal. We are not getting the same. So if we have 12 divided by 19, that gets me 0.63. 11 divided by 16 is 0.69. 9 divided by 14 is 0.64. They're not proportionate. I'm not dividing them by the same number or multiplying by the same number. For the second one, they are similar because when I divide them down, each of those sides, they all divided down to 2. So they are proportionate because they're dividing down to that same number. Do those top two make sense? Yes? Okay. Next one, 8 over 6, 12 over 9, 4 over 3, 4 over 3, 16 over 12. When I divide the top by the bottom for each of those sides matching up, they all get 1.3. So because they divide down to the same number, it is a similar shapes. That's how you prove, yes, I know that these are similar, because I get the same number when I divide the top by the bottom. For this one, I've got 11 to 11, 13 to 13, 10 to 10. They are identical, exact same measurements. So because they are identical, they are congruent. Any questions on either of those? All right, now our review. Remember, this is our last objective before the test. So these reviews are very important. We have practice tests on Wednesday, real tests on Thursday. I am after school on Wednesday if people want to stay after. I had a couple of us when I was walking around say, I'm a little worried about this test. Stay after school Wednesday. We can review it in a small group. I will do a small group review if we want it. If you want to stay after Wednesday, we'll have taken the practice test. You'll have a good idea of the questions that you still have so we can practice a little more so you feel confident for the test on Thursday. So I'll be here, and if you want to come, you're able to come. So a convex octagon has 8 sides. So you had to show 8 sides, and you had to show that all the inside angles are small. No cave-ins, right? So there's no cave-ins, 8 sides. Supplementary angles, you needed 2 angles that equal 180 degrees. So I should have put angle measurements in here. 110 plus 70 gets me my 180 degrees. Obtuse isosceles triangle. So I'm showing it's obtuse that these 2 sides are congruent. And it's obtuse because this angle up here I would show is bigger than 90 degrees. So it's obtuse. Any questions on those 3? On the bottom, a hexagon has 6 sides, so you needed to have drawn a 6-sided figure. Doesn't matter if it's convex or concave, just 6 sides, all closed off. Concave pentagon, we need 5 sides, and 1 side has to be caved in. Vertical angles, we've got that X. Vertical angles always have that X because they share that vertex, and the vertical angles are the ones opposite of each other. I'm showing that they are congruent by those arcs in there. So on the test, if you have to draw a vertical angles, you're going to want to show that they are congruent either with those arcs or with actual measurements that show that they are the same measurements. So any questions on the homework that we just corrected? All right, if you are watching this at home, I hope you're well. I hope to see you soon. Remember to come see me if you have any further questions. Have a wonderful day.